Now let's take a look at the images produced by concave and convex mirrors. We'll start with concave mirrors. A concave mirror has positive focal length because it really converges light. Since it can focus light, a concave mirror can produce real images as well as virtual images. It all depends on the location of the object. Let's look at the mirror equation. 1 over dO plus 1 over dI equals to 1 over F. For images produced by a single mirror or a single lens, object distance dO is always positive. So dO is positive. For a concave mirror, the focal length F is also positive. So if dO is smaller than the focal length, which means the object is placed within the focal length, then, for example, say the dO is 6, and the focal length is 10. That means 1 over 6 is bigger than 1 over 10, which means in order for these two numbers to add up to be 1/10, the dI has to be a negative number. So the dI in this case is a negative number. In fact, we would find, if we solve this equation, we will find the dI to be negative 15. dI being negative means we have a virtual image. And the virtual image formed by a single mirror or a single lens is always upright. And because the magnification M is negative dI over dO, the magnification is going to be positive. And because the dI's absolute value is bigger than dO, so this is going to be a number that is bigger than 1, which means we get a virtual upright image that is bigger. An example of this would be the toy robot problem we did in the last video lesson. The robot was placed within the focal length of a concave mirror, and the image formed was a bigger upright image. And this is a virtual image because it is formed by light ray extensions, and the image is formed behind the mirror where no light rays from the robot can reach. So when we need a mirror to provide a larger upright image, we would use a concave mirror and place the object within the focal length of the concave mirror. What if we put the object at the focal point? If dO equals to F, then that equation will be 1 over F plus 1 over dI equals to 1 over F, which means 1 over dI would have to be 0, which means dI would be approaching to infinity. So we can either say the image is formed at infinity, or we can say that there is no image formed. An example for this would be back when we talked about using a concave spherical mirror to light a match. The sunlight, the parallel rays would converge and focus at the focal point. And because light rays are retraceable, so any object placed at the focal point will give off light and hit the mirror and come out parallel to each other, which means when the light rays go out that way, they are all parallel, which means that they will never meet. Or we can say that they meet at infinity. So dI would be infinity. So in this case, if the object is at infinity, the image will be formed at the focal point. If the object is at the focal point, the image will be formed at infinity. If the object distance is larger than the focal length, the object is placed beyond the focal point, then both of these are positive, and because dO is a bigger number than the F, that means dI must be positive. dI is positive means we are going to get real images. Real images are inverted. And these real images can be either bigger or smaller, depending on the location of the object. Because 1 over dO plus 1 over dI equals to 1 over F. Now, all three of these numbers, dO, dI, and F, are all positive. That means if DO is bigger, DI will have to be smaller. So when we move the object farther away from the mirror, the image formed will be closer to the mirror. And if we look at this ray tracing diagram we did in lesson 13, we can see that we have similar triangles, which means if the image is formed closer to the mirror, the image will be smaller. And when both DO and DI are positive, we can actually switch these two numbers and everything will still work, which means if this is my object and the image is formed over here, that means I can switch over because light rays are retraceable. If this is my object, the image will be formed right there. Because if light rays come from here, it would meet over here. That means the light rays from this point going back that way would meet over there. So if we put the object closer, the image will be farther. If we put the object farther away, the image will be closer. And the closer the image will be smaller, the farther away image would be bigger. Remember the magnification equation? The larger the DI, the bigger the height of the image. So when the DI gets smaller, the absolute value of the magnification would also get smaller. And of course, because the images are inverted, the magnification for real images is negative. Because light rays are retraceable, there's one important thing, that is the light ray that goes through the focal point is going to get reflected and come out parallel to the principal axis. Because we talked about the light rays being retraceable, I just want to emphasize one thing, that is the light rays are retraceable for real light rays, not for the ray extensions. Light ray extensions are not retraceable. Now let's look at the convex mirrors. Convex mirrors have negative focal length because convex mirrors do not really focus or converge light. They diverge light instead. Since convex mirrors do not converge light, they can never form real images. We can also show that by looking at the mirror equation. The DO for a single mirror or a single lens is always positive. And the focal length in this case is negative, because this positive number plus 1 over di has to be a negative number. That means this number must be negative, and di must be negative, which means the image must be virtual image only. A single convex mirror can never give us real images. And if we work out the numbers, we will find that the absolute value of di is always going to be less than f, which means the images are always formed within the focal length. Since the images are formed close by, that means the virtual images are always smaller. So these are virtual upright images that are smaller. So when a mirror forms a smaller upright image, we know the mirror must be convex mirror. An example of this would be the passenger side rear view mirror. The image of the SUV over here is formed within the focal length, and it is a smaller upright virtual image. And remember, a virtual image formed by a mirror is always behind the mirror, where no light gets to.